Hello, everyone. My name is Michael Blake, and I'm a fourth-year mechanical engineering major at UCI. This is my second year working for Phorena as a mechanical engineering intern. Today, I will be sharing with you all some of the things I have worked on, and the main focus of this presentation will be about 3D printing and how to go from parts in Solidworks to a 3D printed appearance model of a product. So, very briefly, what is 3D printing? Well, first, the term 3D printing can be used interchangeably with additive manufacturing. There are several additive manufacturing or 3D printing methods, including selective laser sintering, stereolithography, multi-jet fusion, and more. However, we will only be focusing on the most common method of 3D printing, known as fused deposition modeling, or FDM. FDM can be defined as the process of heating plastic filament to its melting point, and then extruding it onto a build plate, layer by layer, working upwards until a 3D object is created. To learn the anatomy of a 3D printer, we can see a low-end printer in the image on the left. This Cartesian printer has X, Y, and Z stepper motors to feed filament from a spool into the hot end. The main board reads print files and controls the motors, fans, and hot end temperatures accordingly. The image on the right shows a close-up of a hot end. The nozzle at the bottom of the picture is where the filament comes out of. A typical nozzle diameter is 0.4 millimeters. The heater cartridge right above it heats up the heater block to a desired temperature while the thermistor senses the current temperature of the heater block. As filament passes through the heater block, it is melted before exiting the nozzle. The heat break, heat sink, and cooling fan work together to cool down the filament above the heater block to avoid printer jams. Now that we know some of the basics of 3D printing, I'm going to walk you through a 3D printing example in which I import parts into SolidWorks and produce a 3D printed appearance model. The printer we will be using in this example is called the Prusa i3 MK3. It costs $750 if you buy an assembly kit. The build plate volume is 250 by 210 by 210 millimeters. Additionally, the hot end temperature can go up to 300 degrees Celsius, and the build plate temperature can go up to 100 degrees Celsius. In this example, we will be printing in ABS as opposed to ABS plastic as opposed to PLA, because our product contains electrical components which can go up to 100 degrees Celsius. ABS tends to have a higher temperature resistance than PLA, and that's why we'll be choosing it. All right, so here we are in SolidWorks. What you can see in the window is a Phorena product. It's a smart home ceiling light product with various environmental sensors and a lot of smart capabilities. So anyway, we want to 3D print just the main body, which looks like this. And luckily our manufacturer gave us the main body in two different parts, and this will make it easier for us to manipulate. So I'm just going to go ahead and open it with File, Open, and you're going to navigate to your part. We're going to go with the bottom piece. You'll see what that means very soon. And so SolidWorks is actually going to read the step file. The step file is the file we received from our manufacturer, and STEP stands for Standard for the Exchange of Product Data. So this file format was created a long time ago, and it improves, back then it improved the capability of sharing files between different software programs. So right now SolidWorks is reading the step file, and it's going to import it as a SolidWorks part file, like so. And you can see SolidWorks part is the file extension. So we're just going to click OK on Import Diagnostics. So what I know, because I know the dimensions of this part, is that it's larger than the build plate of the Prusa i3 MK3. So we need to split this part into smaller parts. And to do that, we're going to use it's very simple. We're just going to use reference planes and the split tool. So you can access the split tool by go into search and then split. So it'll be right there. But I happen to have it on my toolbar, so I'm just going to select it like that. But yeah, first we need to create a reference plane. So go reference plane, and I want to split it along this seam first. Okay, so this will be a fully defined plane right there. And for clarity, we can expand this. So now you know what the plane looks like. Splitting the whole product in half. So I'm actually not going to split it in half though. I'm going to reference this plane to create another reference plane. We're going to set this one 100 millimeters apart from this plane, and like so. We're going to do this one more time. Oops, sorry, not split. I'm going to do this one more time. And we're going to flip it. So we're going to have a total of 3 planes. And the 2 planes that we're going to be using are planes 2 and 3 that I just created. So now it's time to use the split tool. So I'll just select split. And I'm going to use this plane, this reference plane that I created earlier, as a trim tool under this selection field. And I'm going to select cut part. All right, so now SolidWorks is cutting the part, and I can choose which parts I want to keep. So make sure consume cut bodies is selected. And basically by selecting this, number 2, the highlighted purple part is going to be consumed, and we're going to be left with the part on the left. So let's press the OK button. All right, great. So this part, because I measured the dimensions, I know that this will fit on our printer build plate. So we can actually save this as a. So now the next part is we need to convert this file, the SolidWorks part file, into an STL file. And STL file stands for stereolithography file. And it's actually a mesh file, meaning that it converts the solid body into triangular meshes. So we'll do File, Save As, and we're going to select STL, and we'll save this as an STL file. So as you can see, it tessellates the solid object into triangles, and it can tell us the bytes and the file size. The reason why we're saving this as an STL file is to import it into a slicer software. Okay, so here I am in the slicer software. The slicer software is called Prusa Slicer, and it comes with the Prusa i3 MK3. And the purpose of this slicer and most slicers is essentially to convert 3D object models, and in this case, that'd be the STL file, into instructions for the printer to follow. So I'm going to start by importing the file. That we just saved as in SolidWorks. It's an STL file. All right, so it's in here, but we need to manipulate it to fit on the build plate. So I'm going to rotate it. We're going to rotate it 180 degrees about the y-axis, and then it looks like we need to rotate it about the z-axis. Okay, so now it's rotated. It's still, the blue indicates that it's still outside the build area. So now we'll select the move tool, and this will just be, okay, so it still doesn't fit. We're going to rotate it a little bit more and move it until it's green. So that's great. Now we have our part on the build area. One other thing to explain is we need what's called support material. This is this angle right here that you can see with my mouse. So this is called an overhang, and we need supporting material where my mouse is that can kind of support it as the printer is moving upwards. So we're gonna use the smart capabilities in this slicer. Print settings, support material, generate support material. So essentially what that looks like, if we slice it now, is these green supports. If we don't have these supports, there's a chance that as these top layers are being built, see if we can show you. As these top layers right here are being built, it's a chance that they slip and kind of collapse, like the object will collapse. So yeah, this is the slicer. This is layer 1, and then the slicer software has this feature where we can see the printer building up layer by layer, like so. And finished. So now we're going to select export G-code. G-code is instructions for the printer, and it's a lot of instructions, including the tool path, where the nozzle is going to be moving. It's going to have also the temperature of the build plate, the temperature of the nozzle, or the temperature of the heater block. So we're going to click export G-code, and then we can also see the time of the print and then the amount of filament in grams, which is useful. So export G-code. So you're going to need an SD card. I have an SD card in my computer, and I'm going to select it. All right, so now we can eject the SD card, and we can put it in our printer. Once the SD card is inserted into the printer, you're going to press the knob, print from SD, and select the file that you just saved. And that's it. To quickly recap everything, we're going to start by importing the step file into SolidWorks as a SolidWorks part file. And we're going to use the split tool to make the part smaller and save that as an STL file, which we import into the slicer. And from the slicer, we change the settings and then convert the file into G-code, which is instructions for the printer, and then we 3D print. We're going to repeat that for all the other parts, and then we're going to assemble those parts together using epoxy. And the image on the right is after numerous hours, you can reach the final assembly. So that's it for my presentation. Thanks for listening.